Okay, welcome back. When we left off last time, I had asked you to fill out the questions on your own. And so today we'll be going over those. Okay, for this first question and fill out this chart, it says, put the fulcrum, effort, force, resistant force in each box. Okay, so we're going to use the lever tic-tac-toe that we looked at in the notes. The only kind of lever where the fulcrum is in the middle is the first class lever, and then it goes on the end on the second and third class lever. And then we remember the load goes across the diagonal like a tic-tac-toe, and then in the boxes that are left go the effort force. So then it says, draw a picture. If you can remember this, you can do this. So the fulcrum goes in the middle for first class lever, goes the end for second and third, add the lever bars. And then we're going to put the load across the diagonal like a tic-tac-toe. Then we're going to add the effort force on the end, the effort force on the end, and the effort force in the middle, just like we did here. First class lever can multiply force, and it can change the direction of the force. Remember, the only time it doesn't multiply the force is if we move the fulcrum to exactly in the center. Second class lever always multiplies the force, because the effort arm is always going to be longer than the resistance arm, but it does not change the direction of the force. When you lift up on the handles of a wheelbarrow, the load of the wheelbarrow goes up as well. Then a third class lever does not multiply the force, and it does not change the direction of the force, but you get to put in the force here, and it increases the distance to where the force is output. Okay, a machine is a device that makes work easier. It can multiply force and or change the direction of the force, or like a third class lever, it increases our reach, increases the distance over which the force is applied. Mechanical advantage and actual mechanical advantage. Ideal mechanical advantage is exactly what its name says. It's ideal. It's the number of times a machine would multiply your force if nothing was lost to friction. So it's perfect, it's ideal. Now, we can't actually make a machine like this on Earth. All of our machines have some kind of friction in them. So when we talk about mechanical advantage, the actual mechanical advantage is a machine. It's what a real machine does. It would measure if we built one and we measured how many times it was multiplying our force. 6 different types of simple machines. Okay, we can break all of them into either levers or some kind of incline plane. So a lever is a lever. A pulley is a modified first class lever. And a wheel and axle is also a modified first class lever. Remember, the axle is like the fulcrum, and then you have an effort arm and a resistance arm like the spokes of the wheels. The incline plane is obviously classified as one of the incline planes. A screw is an incline plane wrapped around a post, and a wedge is an incline plane that moves. Which system of pulleys has the greatest mechanical advantage? It's block and tackle, and you count the supporting ropes. What are the 3 types of levers? First class like a seesaw, second class like a wheelbarrow, and third class like a broom. A machine that does work with only one movement is a simple machine. A combination of 2 or more simple machines is a compound machine, which these are most of the machines we use. Cars, airplanes, buses, trucks, all those things are compound machines. And what is the trade-off for a machine multiplying your effort force? You have to do the work spread out over a big distance. You have farther to go. You don't get anything for nothing. So like with the incline plane, you have to slide it up a long incline plane. The wheel, you have to turn a big radius of the wheel to turn an axle. You know, just a small amount, you turn the radius of the wheel a big distance. Pulleys, you have to pull down however many ropes, so you pull down many more times, feed a rope, but it does multiply your force. When we come back next time, we'll be starting a new unit. I hope everybody's having a great day, and we'll see you next time.